Okay, next problem up is number 44. We have few options on 44. And let's see if we could tackle a few of those. So 44. I see a problem with a radical, no easy use up there, so I'm thinking one of two things. Either I let u equal the entire radical. Normally we let it be what's underneath the radical, but you could, I'm going to do both of those. Let's say you let u equal what's underneath the radical, and you know if you take a derivative, you're going to have e to the x dx, which is not there. Which means to get this dx by itself, I need to solve this equation for x, so I can do that. And again, the purpose here is for me to get, when I take a derivative, simply dx. And now if I did it this way, I'll notice that this is going to become the integral. The green part is really the square root of u. And dx is simply 1 over u minus 1 u. And here I'll make another substitution. Here I would say, you know what? Let w equal radical u. And again, I square both sides to get rid of this. W squared equal u, and 2w dw equal du. This becomes the integral. And let's see how this plays. I know that this is w squared minus 1, and du is 2w dw, and I have this, which is my initial w. And here I'm looking at twice the integral of w squared over w squared minus 1 dw. I have to use long division. And this would be twice the integral of 1 plus 1 over w minus 1 into w plus 1. And guess what? You could do partial fractions on this and figure that out. Don't forget to substitute w back into u, and u back to 1 plus 2. Now, I could have done this problem slightly different. I could have started this problem by letting u equal the entire radical. That saves you a bit of time. U squared minus 1 natural log equal to x. So dx is 1 over u squared minus 1 times 2u du. And this in turn will transform this integral and make it the integral of u. And dx is simply twice times u over u squared minus 1. And do you notice you are at this stage? And you could do the same thing and just proceed. So, you can't really get it wrong or right. I do assume that you do this the longest possible way on a test, so it's not a problem. Time shouldn't be an issue. I want to look at 48. Oops. 54 here. So 48, how does that look? First order of business, I'm going to let u equal 1 minus x squared. So, if I take a derivative of this, du is negative 2x dx. That's good news because I have this right here. I'm off by a constant. That's an easy fix. This becomes the integral. So this part right here is my negative 1/2 du. And I have a square root of 2 minus, and this part was really my u. And I'll make another substitution. I would let w equal the square root of 2 minus u. Since I don't have a radical in the denominator, I would know that I need to square both sides so that I can get just a du. And if I swap those, u will equal 2 minus w squared. Du is negative 2w dw. So this is negative 1/2, the integral, and this is my w, and du is a positive 2 times w dw, and there it is. Did I miss anything? Du oh, that's it. Let me just proceed and finish the problem. But I have a feeling I messed it up somehow. That's w squared. Let me just double check my steps really quick. Okay, I found it. This is actually the square root of u. So I'm gonna leave this part. I'm sorry. So this part is fine. I am gonna let, in this case, w equal 2 minus square root of u, and here we're gonna swap those and say square root of u equal 2 minus w, and u equal 2 minus w squared. du is 2 into 2 minus w dw with a negative. So this is negative 1/2 the integral square root. This part is actually my w. And du would be a negative 2, so that's a positive 2, times 2 minus w dw. That's better. So this is the integral of 2 w to the 1/2 minus w to the 3/2 dw, and we will plug down. Don't forget to substitute w to u and u to x. Alright, oh boy. A couple more to go. I want number 54, 64, 74, and 80. So number 54, is it showing? Yeah, it's right there. 54 is next. This problem, since it's a square, well, it's pretty much one step to go. Not to underestimate this, it has few things. This is x cubed over 3. Here, I'm going to get twice if I let u equal x, du is dx, and dv is sine of x dx, so v is negative cosine of x dx. So that's negative x cosine of x plus the integral of cosine of x dx. And this sine squared is actually the integral of 1 minus the cosine of 2x divided by 2 dx. So I'm looking at x cubed over 3 minus 2x the cosine of x plus twice the sine of x plus 1/2 times x minus the sine of 2x divided by 2 plus. There. I was going to put 3 dots, but we have time. I have about 4 minutes to go, and I'm almost done, so might as well. Another nice problem to look at is number 64. Again, I know you guys disagree, but I think it's a lot of fun. Okay, a radical within a radical. We dealt with that a few times, so let's start again. There are a couple of ways you could do that. I suggest you start with this step at a time until you get this. First, I'm going to let u equal the square root of x. You could let it be the square root of x plus 1 if you want. U squared equal x, so 2u du equal dx. A step at a time. So this is, let's see, I have a square root still, but I let this du, and that's going to be a plus 1, and dx is 2u du. That's what I have so far. The next level, I'm going to go ahead and say let w equal u plus 1. Well, guess what? The variable. Actually, I could switch those. Yeah, what do you know? Yeah, switch those. dw is du. Look at that. Wouldn't that be the square root of w? And du is dw. And guess what? U would be w minus 1. And why is that significant? Because that's w to the 1/2 minus w to the negative 1/2. And you could wrap it up. Again, don't forget to go back from w to u and u to x. Two more I want to look at. And if I look at problem number 74, a bit of algebraic manipulation. If I really play with this, I'm really looking at the integral of 4 to the x over 2 to the x plus 10 to the x over 2 to the x dx. Actually, I'm going to wrap it up with this because I'm already at 11 minutes. That is 4 over 2 to the x plus 10 over 2 to the x dx. That is the integral of 2 to the x plus 5 to the x dx. And that is, you take a derivative, you multiply by natural log of 2. You take an antiderivative, you divide by natural log of 2. So on this section, this is the one section I'm not sure what to assign, so I'm going to give you an option. Homework. And this is section 7.5 on page 547. Numbers 1 through 81. I don't know what to choose. Odd, every other odd, every other odd. I needed to submit some problems. You could do a few of each. Remember, the more you do, the better off you are. Alright?